All right, we're calling the theme of this video "Third Time is a Charm." This is the third time I'm trying to film it, and my iPad is just not cooperating. It's just not saving it. So, just to warn you, there are already like writing all over my slides because I couldn't reprint them, especially for the third time because I'm out of ink on my printer at home. So I'm sorry that you guys will get the appended version. But these are notes you should take. We already knew this relationship that cosine and sine were the xy on the unit circle. And so that would make tangent y over x. And now we're introducing our reciprocal functions where secant is a reciprocal of cosine, cosecant is a reciprocal of sine, and cotangent is a reciprocal of cotangent. So these relationships are really important and very useful, so you'll want them in your notes. When we get to identities, you'll want these in your notes showing the relationship between the functions for the reciprocal relationships. All right, so you can pause and copy those down if you want. Slide 2 has some on the top, but what we really want to focus on is looking at those trig ratios for a right triangle and how those are related with the opposite, adjacent, and hypotenuse side. And so we have SOHCAHTOA over here, and our reciprocal relationships, you'll notice, are the opposite of whatever they're reciprocal to. Down here, I have a reminder that the Pythagorean theorem that goes with the unit circle is x squared plus y squared equals 1, because the hypotenuse is always 1, and the sides are made up of xy coordinates. But here on this slide specifically, we're looking at a point that is not on a unit circle. It's just on a triangle somewhere in an xy coordinate system. So you can see here's your triangle over here. And I took the 3, 4 and put it as the xy of this triangle. And I wasn't given the hypotenuse, so I had to use the Pythagorean theorem to find the hypotenuse. You can see I did that there. And then I went through, and part of your homework or your tasks associated for this week is finding all 6 of the reciprocal relationships, their exact values. And so you can see the sine of theta is always here next to the origin, is opposite over hypotenuse, so 4/5. Cosine is 3/5, adjacent over hypotenuse, and tangent is opposite over adjacent, so 4/3. And then we have our reciprocal relationships, which are kind of smushed in. So let me do those over here. Cosecant is the reciprocal of sine, so it's going to be 5/4. Secant is the reciprocal of cosine, so it's going to be 5/3. And cotangent is the reciprocal of tangent, and so it will be 3/4. So we have all 6 of our relationships there. All right. So how do we apply these relationships? Well, some of the things you might see in the book, it says evaluate all 6 trig functions for when theta is 5 pi over 4. So in the previous slide, we evaluated given a point, and now if we're given an angle, and this is where the unit circle comes in. So they want to know where 5 pi over 4 is. Well, it's over here in quadrant 3, and the xy values are -√2 over 2 and -√2 over 2. So you can see I drew that in on my little triangle here, or my circle here. And so even without a unit circle, you could find this because you would know that your reference angle here is pi over 4. So this is a 45, 45, 90 triangle. But we're just going to use the information given from the unit circle. So you can see cosine and sine are kind of gimmies. Those are the exact point we found on the unit circle. And then if tangent is the division of those 2 points, y over x, then tangent is 1. And if cotangent is the reciprocal of 1, it's still 1. So we got 5 of these relationships pretty quickly. The ones that are a little harder are secant and cosecant, especially because there's radicals. So if you take the reciprocal of cosine, you get 2 over negative or negative 2 over square root of 2. Then you have to rationalize it, and when I do all of that work, I get negative root 2. Well, I kind of cheated on this one. I didn't redo the work knowing that I started with the same, so I get the same answer. So here's this full slide. I'm using a different app on my iPad to film, and I can't zoom in and zoom out, so I don't like it, but I didn't want to film this one more time. Tired of hearing myself talk. Maybe you guys are getting tired of hearing me talk too. I don't know, maybe. All right, so very similar to the previous slide but instead of calling it theta, we're calling it t. So, and they want you to evaluate the six trig functions for the given value of t. T is the same as theta. It's just that when we get to graphing sine, cosine, tangent, and all the functions, they call it t because you're finding the period along the x-axis, and period denotes time, so it's t for time. All right, so they're giving us this 11 pi over 6 on the first one, and if I get my unit circle, I see 11 pi over 6 is over here in the fourth quadrant. I got a reference angle of pi over 6, so this is a 30, 60, 90 triangle. This specifically is my 30-degree angle. And you can see my xy values are here. So using that information, I just filled in my xy values. And then I did the same thing I did on the previous slide, where I said tangent is y over x. And so that's negative 1/2 divided by root 3 over 2. And just a quick reminder, when we are doing division of fractions, we flip the second fraction and multiply, which is what I did in this second step. That gave me negative 1 over root 3, which I had to rationalize. And so when I get all said and done, I get a negative root 3 over 3. Now the rest of these are just reciprocal relationships, so we can flip our previous answers. So cosecant, if it was negative 1/2 for sine, it's just negative 2. Secant is going to be the reciprocal of root 3 over 2, which then you have to rationalize. Same with tangent and cotangent. This is the reciprocal, so I have to rationalize that, and I get just negative root 3. All right, B is easier but trickier. So it asks for a reference angle, and if you look at the unit circle, 3 pi over 2 is here. And so my reference angle is pi over 2, but if you remember the definition of a reference angle, it has to be an acute angle, which means it's less than 90 degrees. So it's not really a reference angle, but I'm just putting it down there as that's the distance between the 3 pi over 2 and 2 pi. So you can see your values here. Our cosine is 0 and sine is negative 1, and I filled those in. And then we get a couple of weird answers here because tangent is y over x, and when I divide by 0, I get undefined. Cosecant, again, is the reciprocal of sine, so it's just negative 1. And then secant, I get another undefined because cosine was 0. And then cotangent's a little tricky. Like you think, oh, well, how do you take the reciprocal of undefined? You don't take the reciprocal of that. You take the reciprocal of this. Or you can also think if tangent is y over x, then cotangent is x over y, which is 0 over negative 1, and that's just 0. All right, anytime you guys need to pause, I'm going through it faster because I'm not riding along with you. Due to my disaster of filming, just go ahead and pause the video or rewind. Okay, this is where we're going to end. We'll definitely see this a little bit in the practice associated with this. So notice that we're not given an angle, we're given a point. And we don't care about the angle. We are not trying to find an angle. We're trying to find the exact values associated with this point. So I kind of drew that in. I know that negative 7/25 and 24/25 are on the unit circle, and they're here in quadrant 2 because that's where x is negative but y is positive. So some angle t, it's not asking me to find that. It's saying find all of the 6 trig functions, find their exact values. And anytime you hear the word value, they're wanting these numbers out here. They're not wanting the angles in there. So again, cosine and sine were spelled out in the problem. Tangent, you can see I divided y by x, meaning I took my second fraction and multiplied. And so those 25s cancel out and I get negative 24/7. And then it ended up being kind of easier because I don't have any radical signs in this one. So cosecant is a reciprocal of sine, so I just flipped it. Same with secant and cosine, and then cotangent and tangent. This is usually where the questions start coming in for trig. So if you have questions, remember I can have office hours any day of the week, but specifically Tuesdays and Thursdays at 1. You can email me. I can make you, I have extra example problems I can make a video on, should I actually be able to upload videos in the future. Anyway, I hope this video is helpful, and just let me know whatever you need that I can get to help.